Hi students, welcome to physics class. Today we are going to discuss some important numericals. Now this is our numerical number 1. Prove that the resultant velocity v of translation of a rolling body like a ring, disc, cylinder or sphere at the bottom of an inclined plane of a height h is given by velocity v is equal to 2gh by 1 plus k square by r square, where k is radius of gyration, r is the radius of the body. The body starts from the rest at the top of the plane. This is the question. Now see the solution. Take an inclined plane here. The angle is theta. A body is here. This is its center. The body is rolling downward direction. When it is rolling downward direction from point C to B, it has two motions. One is rotatory motion. The second one is translatory motion. So now we have to calculate both. Therefore, when the body rolls down an inclined plane of height h, apply principle of conservation of energy. That is, potential energy at top is equal to kinetic energy of translation plus kinetic energy of rotation. That is, potential energy top is equal to kinetic energy translation plus kinetic energy rotation. That means mgh is equal to 1 by 2 mv square plus 1 by 2 mk square 1 by 2 here I omega square. Consider this is equation number 1, but I is equal mk square. Equation number 2, and also omega square is equal v square by r square. Equation number 3, but I is equal to mk square and omega square is equal to v square by r square. Consider equation number 3. Now equation 2 and 3 substitute in 1. Therefore mgh is equal to 1 by 2 mv square plus 1 by 2 mk square into v square by r square. gh is equal to 1 by 2 v square into 1 by 2 k square v square by r square. Therefore 2gh is equal to v square into 1 plus k square by r square. Therefore v square is equal to 2gh by 1 plus k square by r square. Therefore the required equation, we already proved that v square is equal to 2gh whole by 1 plus k square by r square. Now see numerical number 2. A solid sphere rolls down two different inclined planes of the same height but different angles of inclination. Will it reach the bottom with the same speed in each case? Next one, will it take longer to roll down one plane than the other? If so, which one? Which one and why? This is the question. Now go for answer. Now see, we are going to discuss solution. Take two inclined planes. Here these are A, B, C, D, E, F. Here the height is H. Here also the height is H. One body is here. Here also same height, body is here. Consider the angle is theta 1. Here the angle is theta 2. Means that the angle of inclinations are different. Now see, apply principle of conservation of energy. Therefore, 1 by 2 mv square plus 1 by 2 I omega square is equal to mgh. Consider equation number 1. Therefore, I is equal to 2 by 5 mr square. Consider equation number 2. Now, omega square v square by r square. Equation number 2. Now, equation 1. This is equation number 3. Now, equation 2 and 3 in 1. Therefore, we will get 1 by 2 mv square plus 1 by 2 into 2 by 5 into mr square into v square by r square is equal to mgh. Therefore, 1 by 2 mv square plus 1 by 5 mv square is equal to mgh. What happened? R square cancel, 2 get cancel. Therefore, 1 by 5 mv square. From this one, v square whole by 2 plus v square by 5 is equal to gh. Therefore, 5v square plus 2v square whole by 10 is equal to gh. Therefore, 7v square by 10 is equal to gh. Therefore, v square is equal 10 by 7 into gh. Therefore, v is equal root of 10 gh whole by 7. That means since h is same in the two cases, V must be same. Therefore, V must be same. If it reaches the bottom with the same speed, that is the time taken to roll down the two planets, the time taken to roll down the two planes will also be the same. Since their heights is the same, my dear students, this is about this numerical. My dear students, now we are going to discuss numerical number 3. A loop of radius 2 meters, weight 100 kg. It rolls along a horizontal floor so that its center of mass has a speed of 20 centimeter per second. How much work has to be done to stop it? This is the question. Now, given what the examiner given, R is equal 2 meters and M is equal 100 kg and V center of mass is equal to 20 centimeter per second, that is equal 20 into 10 to the power of minus 2 meter per second. Now, solution. Total energy of loop is equal to 1 by 2 mv square plus 1 by 2 I omega square. That is equal 1 by 2 mv square plus 1 by 2 mr square into v square by r square. The reason is I is equal mr square and omega square is equal to v square by r square. Therefore, the total energy of loop is equal to 1 by 2 mv square plus 1 by 2 mv square gives mv square. That is equal to 100 into 20 into 10 to the power of minus 2 whole square gives 100 into 400 into 10 to the power of minus 4. Therefore, W is equal to 4 joules. My dear students, we have to solve such type of the numericals. I hope you understood this numerical. Thank you very much for watching this video.